Okay guys, so today I just want to show you about Newton's law of linear approximation. So that's the one that we use to find the x-intercept. So once you deal with any kind of crazy polynomial with the high order power, so the Newton's method is basically just the point slope form. So if you recognize the point slope form, which is considered y minus y1 equals m times x minus x1. If you try to derive it with that f of x1, f prime of x1 for the slope, and then you try to get rid of that y, or just let y equal 0, you'll solve for x. So eventually it's going to be considered the Newton's method. Okay. So we're going to be using calculator to demonstrate the process. So we just turn on to the TID4, and let's say we do have a function. So let's set up the function here. So we do have a functions of x to the power of 3 plus 2x minus 4. And then we're using x1 equals 1 as the first approximation. Okay. So x to the power of 3. So go to y1 and then just put in x to the power of 3. Minus 2x plus 4. So just making sure that we put in the right form. It's actually minus 4. So that's the original function. And then for y2 you want to put in the derivative. So the way to put in derivative, we set up math and then 8. So n derivative and then d over dx, that's what you want to put in. And then over here we put in vars, y vars. Okay, let me just show something here real quick. So for vars, and then go to y vars. So put in y1. And then this one is taking the derivative with respect to x. And then for y3 we put in the Newton's method, so it's x minus y1 over y2, which is the original function, over the derivative. So again, vars, y vars, functions, y1, and then divided by the derivative, y2. So go to vars, y vars again, and functions, but this time you want to select y2. And now from here we can use that xy table. So in order to set up the table, you want to go to second window and make sure that you put in the independent variable as the as mode, and then dependent variable, that's automatic. And then we go to second and then table. So the first approximation, so we're using 1. Okay, so let's put in 1. And then for y1 we got -5, which is the y value. Derivative is 1. And then for the Newton's approximation, that's 6. And then we're using 6 to find out the next approximation. And we got 4.1132, which is very close. And then we're using that y3 value again, so we put in 4.1132. So we got 2.9367. Okay, and then put in 2.9367. And this one is very close. It's 2.2894. Now, a lot of students wondering, where do you stop? So you're going to stop with the y3 value, which is the same as the x value that you put in. So the next one you want to try, you want to put in 2.2894. So this time we end up with 2.0401. Okay, so let's try that one more time. So put in 2.0401. And we got 2.0009. Okay, one more time. 2.0009. And that's exactly 2. And then put in 2. And that's what we have. So for the x-intercept, the first x-intercept for this graph, that would be x equals 2. Thank you for watching the video today.